Hey there, what's going on? Today we're looking at investigating human priors for playing video games by Rachid Dubey, Pulkit Agrawal, Deepak Pathak, Tom Griffiths, and Alexei I. Efros. So there is a paper to go with this, but I actually don't want to get into the paper too much in order to not reveal too much of what's coming. But basically, they're trying to investigate what makes video games work for humans. So what do humans pay attention to? What priors bring humans into a video game? And the fun thing is they've created these games where they ablate these individual priors, and we are going to play them. So the original game right here, as you can see, is kind of this Montezuma's Revenge type of game. So you only need the arrow keys. If you go to a bad blob like this, then you die. And you can jump on them, and you can use the ladders and the spikes. They'll hurt you if you jump on them, and also if you fall down between the platforms. So what you got to do is basically get the key, then go to the door over here, and bada boom. Cool. So let's try out. So they basically ablate different things here. Masked semantics means that you don't know what the objects are anymore. So you might go over here and you might be, what's this green thing? Can I jump on it? Oh. So we're probably a bit biased because we've seen the game before. So we know that these are the pink ones are the bad ones, and that's the key. So we should probably get it. But you can imagine that it is a bit harder, but you could still solve it, right? Reverse semantics is very interesting if you play it for the first time, because all of a sudden now, there's the coins, and the fire. But I think humans could probably still figure it out with like some minimal trial and error, right? This ice cream cone, you realize, okay. Now it gets interesting, because right now we've always had sort of, we know that there's an object and there's no object on the platforms, but now these are masked. So basically you don't know what's like a relevant object and what isn't. So I know that there's like a bad thing here and a bad thing down to the left. So I'm gonna guess these light pink things are the bad things. Yeah, these are the ladders. Cool, bad thing right here. We are rocking this. Okay, key, that's the key, and the door. So it gets harder because you kind of have to remember the colors, right? I know that the light pink ones are the bad squares. Still solvable. So let's jump over these on the left because these get really, actually let's go into here. So masked affordances. What they're saying is that, okay, you can kind of, from the way something looks, you can tell what you can do with it. For example, the platforms, you can, jump on them, and the background is sort of empty space. So you know that there's nothing much happening there. So they trying to take that away by simply retexturing all the objects here, such that you don't know how you can interact with them. And it does get significantly harder because, okay, so these green ones are the platforms right here. So, but I can still see that. That must be the ladder, right? You can imagine if you were playing this again for the first time that this is significantly more difficult, but you still see the key and the green ones being the platforms. We got this. Now it gets harder. Masked visual similarity. So this is where they say, maybe, as we did so far, maybe you as a human can kind of make out that things that are visually similar to each other, you can do the same things with. Like we said, the green ones are probably the platforms. So they took it away. Gee. Okay, so that must be, okay, can't go here. Fell down. Let's try again. This is a platform. Is this one here? Yes, these are platforms. That was easy. Too easy running into that bad blob there. Okay, the ladders are still like this, but then, okay, yeah, this gets harder as you can. Gee, okay, I'm too dumb to remember from before. I'm like the ideal subject because I don't remember. How did this work? I'm going to solve this, just so you know. Even if this video gets to 50 minutes, I'm going to make it through this. Okay, here we can. Okay. See, my short-term memory is so bad. Okay, we got the key. Now just get over to the door. Door's over there. Yeah. Okay. Now let's wipe the short-term memory again. Here, changed ladder interaction. where they basically say, okay, one of the things that you could know from the real world is how, you know, these objects work in the real world. So there's not really any pink blobs with evil faces. There might be spikes, yes, but ladder is something you know that works. So if you want to go up here, that doesn't work, so you kind of have to figure, okay. So you have to go kind of left and right to go up the ladders. And so that one I actually tried before, and I figured that out pretty quickly. I think humans are able to figure that out fairly quickly, because you're kind of on the ladder, right? You can actually go down easily. You're on the ladder, and then it kind of doesn't work, and then you kind of try to wiggle because there's two of them. So I don't think that's necessarily super hard. And now, it feels a bit like, you know, this Super Mario Maker thing where people just try to make levels as hard as possible and trick you with trick blocks and invisible stuff. This is hard. So the direction of gravity. So now the left key jumps, right? And here this key, so this is extremely, extremely hard. Because I have to like think about every move I make before I do it. And Jesus. Okay, no. This is so unintuitive, for real. Yeah, got it. Okay, really try this out. This is crazy. Yeah. Okay, so the last thing is we combine all of it, I guess, except the changed gravity and changed interaction. So now all the priors, all the visual object priors removed. This is King's discipline right here. Okay, so we figured out we're the blue. Cool. So where's the next? This is the next platform. Where's the? Okay. There must be like a yeah. Take that. Okay, but we know the next. So we can't really generalize from this because we know the next bad blob isn't going to be the same color, right? Okay. The white. Then this. I know there's a bad thing here, but we'd have to figure this out. So basically, kind of the point of the paper, I think, is to say that this is what you're doing to our... No, the spikes. This is what you're doing to RL algorithms, if you're in the most case. So they simply have to go and to basically try every single thing and remember what worked and what didn't work. Now, of course, the RL algorithms can also exhibit, like, can also use the visual similarity. That was the key. Yeah. Let's go to the door. No, there's like a bad thing here, right? No, spikes. Okay. So either we build these priors into the RL algorithms if we want to get them to human level, or we have some sort of learning these priors before we let the people go, you know, onto a paper, or I don't know, or we just, you know, take it that RL algorithms, you know, have to figure all of this out by themselves. So they ablate these things right here. You can see the masked object identity makes kind of the biggest difference in terms of time, number of deaths, and number of states explored. Reverse semantics. I believe these are humans that are, you know, trying it for the first time, and they're just like, ooh, an ice cream. So it can also hurt, right? The RL algorithm wouldn't be super impressed by it looking like an ice cream. But the human is very much. And the crazy thing here, you can see exploration in the original game and then exploration in the no object prior game, especially if you play this for the first time. This is just mad. Like, no freaking way. I would actually like love to see video games like this coming out. This would be the worst selling video game of all times, where dynamically it just removes these kind of priors. But I think it's a really fun way to investigate what humans learn and what they already bring into the game. So here they have another game, and they do this same thing on an RL agent, and you see here the RL agent just don't care about any of these things except visual similarity. So visual similarity helps the RL agent to generalize across the game. So if you see a bad blob, the next bad blob will look similar, and that's sort of kind of an invariance that we know they can exploit since they're using convolutional neural networks and so on. But I think it is really drawing attention to the importance of prior knowledge in reinforcement learning and human knowledge. So in this game right here, where you have these hidden rewards that the human doesn't see, right? But if they kind of touch it, they're kind of coins. And the human performs way worse than the RL agent, because the RL agent will actually try those things out. And the human having the prior that the black thing, right, they don't see the yellow boxes, that the black thing is just empty space, they won't even explore that. So maybe, you know, that is something to think about with respect to building RL agents. All right, I don't want to go into the paper too much. It's a very cool paper, but we're here to play games, and I invite you to read the paper, check out the website, try these games for yourself. They're a lot of fun, especially if you try them the first time, and bye-bye.